The morning of June 5, 1942, dawned hot and humid over the Dutch Harbor Naval Station in Alaska's Aleutian Islands. Lieutenant Commander John Smith Thatch stood among the wreckage of what had been a routine morning just 48 hours earlier, before Japanese carrier aircraft had swept down from the fog-shrouded skies in a devastating surprise attack. The raid had killed 25 Americans and left the base's fuel tanks burning, but it had also left behind something far more valuable than the destruction it caused, an intact enemy fighter plane that would revolutionize American aviation tactics for the remainder of the Pacific War. The Mitsubishi A6M Type 0 fighter lay crumpled in a boggy marsh 3 miles from the airfield, its distinctive rising sun insignia still gleaming despite the mud splattered across its wings. Marine Corporal William Henderson had spotted it during a patrol sweep, initially mistaking the downed aircraft for American wreckage until he drew close enough to see the enemy markings. The discovery sent ripples of excitement through the command structure. Never before had American forces captured a Zero in such remarkably complete condition. Within hours, a recovery team assembled under the direction of Navy intelligence officers who understood they were looking at an intelligence bonanza. The Zero had earned a fearsome reputation throughout the opening months of the Pacific conflict. At Pearl Harbor, over the Philippines, and across the sprawling waters of the South Pacific, this sleek fighter had carved through American aircraft with terrifying ease. Allied pilots spoke of it in hushed, respectful tones. A machine that could outmaneuver anything the Americans put in the sky, that could climb faster, turn tighter, and strike with deadly precision before vanishing into the clouds. The Japanese aviators who flew them seemed invincible, racking up kill ratios that defied belief and left American squadrons decimated. According to military intelligence reports compiled by the Office of Naval Intelligence, documentation that would later be declassified in 1973, American pilots had filed dozens of after-action reports describing encounters with the mysterious Japanese fighter. These accounts painted a picture of an aircraft that seemed to defy the known principles of aerial combat. It accelerated impossibly fast, turned inside the radius of every American fighter, and possessed a range that allowed it to escort bombers on missions that stretched hundreds of miles across open ocean. As the recovery team began the painstaking process of extracting the Zero from the Alaskan muck, Marine Aviation Engineer Captain James Miller conducted a preliminary examination that would yield the first shocking revelation. Miller had designed aircraft protection systems before the war, and immediately began inspecting the cockpit area, running his hands along the fuselage where he expected to find the standard armor plating that protected every American fighter pilot. His fingers found nothing but thin aluminum skin, barely thicker than the metal used in a household appliance. He checked again, certain he had missed something. The seat back contained no protective steel plate. The fuel tanks lacked self-sealing rubber layers. The windscreen was standard glass, not bulletproof transparency. Captain Miller straightened up slowly, his face registering disbelief. He called over Lieutenant Douglas Chen, an intelligence officer who had studied Japanese aviation manufacturing before the war. Together, they conducted a more thorough inspection, their flashlights illuminating every corner of the cockpit. The conclusion was inescapable and almost incomprehensible. The most lethal fighter aircraft in the Pacific Theater flew into combat with absolutely no armor protection for its pilot. The captured Zero arrived at Naval Air Station North Island in San Diego, California, on July 15, 1942. Transported aboard a cargo ship that had taken extreme precautions to protect its valuable cargo. Within 24 hours, the most sophisticated aircraft analysis team ever assembled by the United States Navy descended upon the Japanese fighter like surgeons preparing for a complex operation. Led by Commander Edward Henry Heinemann, who would later design the legendary Sky Raider attack aircraft, the team included structural engineers, propulsion specialists, aerodynamicists, and combat pilots eager to understand the machine that had haunted their nightmares. The systematic disassembly revealed a design philosophy so radically different from American aviation doctrine that it initially seemed almost suicidal. Every component of the Zero had been engineered with a single obsessive focus: reducing weight. The engineers discovered that chief designer Jiro Horikoshi and his team at Mitsubishi had created an aircraft that weighed barely 4,000 pounds empty, nearly 2,000 pounds lighter than the Grumman F-4F Wildcat that served as the Navy's primary carrier fighter. This weight advantage translated directly into the performance characteristics that had made the Zero so dominant in combat. The fuselage construction demonstrated extraordinary craftsmanship, but minimal structural redundancy. Japanese engineers had used a new aluminum alloy designated extra super duralumin, which offered exceptional strength-to-weight ratios, but required manufacturing precision that American mass production methods could not replicate. The wing spars were milled to tolerances measured in thousandths of an inch, creating structures that were simultaneously strong enough to withstand combat maneuvers, yet light enough to permit the Zero's remarkable agility. Each component had been weight-optimized to an almost obsessive degree. Even the pilot's seat consisted of nothing more than a thin pad attached to a minimal frame. The propulsion analysis revealed similar weight-saving measures. The Nakajima Sakai 14-cylinder radial engine produced barely 1,000 horsepower, significantly less than comparable American engines, yet the Zero's lightweight meant it achieved performance that seemed to violate physics. The fuel system consisted of unprotected tanks holding 156 gallons of high-octane aviation gasoline, positioned directly behind the pilot and in the wings, with no self-sealing capability whatsoever. A single incendiary bullet could transform the entire aircraft into a fireball. Historical documents preserved at the National Archives, including technical analysis reports compiled by the Navy's Bureau of Aeronautics, provide detailed insights into the American engineers' growing understanding of Japanese design priorities. These reports, particularly those authored by Commander Heinemann's team, noted that American aircraft designers had always assumed certain features were non-negotiable: armor protection for the pilot, self-sealing fuel tanks, robust structural design that could absorb battle damage. The Zero's designers had rejected every one of these assumptions. Testing pilot Lieutenant Commander William Leonard, who had survived multiple encounters with Zeros over Guadalcanal, flew the captured aircraft on August 2, 1942. His post-flight report contained a single word underlined 3 times: magnificent. The Zero responded to control inputs with a precision and immediacy that made American fighters feel sluggish by comparison. In turns, it could literally pivot around its own axis, bringing guns to bear while American aircraft were still wallowing through their maneuvers. The visibility from the greenhouse-style canopy was exceptional. The controls were light and responsive, but Leonard also noted the psychological burden of flying an unprotected aircraft into combat. American pilots sat behind armor plate, knowing that protection might save their lives when enemy rounds found their aircraft. Zero pilots flew with the knowledge that any hit, anywhere, could prove fatal. This realization transformed American understanding of the air war in the Pacific from a simple question of aircraft performance into something far more complex. The Zero's radical design choices reflected strategic decisions made in Tokyo throughout the 1930s, when Japanese military planners faced a fundamental dilemma that would shape their entire approach to the coming Pacific conflict. Captain Minoru Genda, one of the Imperial Japanese Navy's most brilliant tactical minds, had argued forcefully for a carrier-based fighter with unprecedented range and maneuverability, characteristics that would allow Japan to project air power across the vast distances of the Pacific Ocean, where the coming war would inevitably be fought. His vision required compromises that American designers would never accept. The specifications issued by the Japanese Navy in 1937 demanded performance characteristics that seemed mutually exclusive. The new fighter must achieve a maximum speed exceeding 300 miles per hour, possess a combat radius of more than 600 miles, climb to 20,000 feet in under 8 minutes, and maintain the maneuverability necessary to defeat any opponent in a dogfight. Additionally, it needed to operate from the small carrier decks of Japan's expanding naval aviation fleet. The requirements represented wishes more than realistic engineering goals. Jiro Horikoshi, who assumed leadership of the design team at Mitsubishi, understood immediately that meeting these specifications would require abandoning conventional wisdom about fighter aircraft design. Born in 1893 in Fujioka, Gunma Prefecture, Horikoshi had studied aeronautical engineering at Tokyo Imperial University before joining Mitsubishi in 1927. His earlier designs had shown a consistent emphasis on aerodynamic efficiency and weight reduction, but the Zero would push these principles to their absolute limits. The decision to eliminate pilot armor and self-sealing fuel tanks was neither callous nor ignorant. It was calculated based on tactical doctrine that prioritized offensive capability over defensive protection. Japanese naval aviation philosophy, heavily influenced by samurai warrior traditions that dated back centuries, emphasized aggressive attack and individual pilot skill over mechanical protection. The best defense, according to this thinking, was superior performance that allowed pilots to dictate engagement terms and destroy enemies before they could return fire. Information compiled by the United States Strategic Bombing Survey after the war revealed that Japanese aviation leadership viewed armor as an admission of defensive thinking incompatible with warrior spirit. This philosophy was reinforced by the high skill level of Japanese naval aviators in the war's early years. Pilots like Saburo Sakai, who would ultimately be credited with 64 victories, and Hiroyoshi Nishizawa, the most successful Japanese ace with over 80 kills, demonstrated that superbly trained pilots in highly maneuverable aircraft could dominate aerial combat. These men had trained for years before entering combat, practicing formations and tactics until they became second nature. Their skill allowed them to exploit the Zero's advantages while minimizing exposure to enemy fire. The captured Zero's examination coincided with increasingly desperate reports from the Solomon Islands, where the battle for Guadalcanal had evolved into a grinding war of attrition. Marine pilots flying from Henderson Field faced daily attacks by Zero fighters that seemed to appear from nowhere, shoot down American aircraft, and vanish before reinforcements could respond. The psychological impact of facing an apparently invincible enemy was wearing down American squadrons faster than combat losses. Intelligence reports indicated that Japanese pilots had developed tactics specifically designed to exploit the Zero's strengths. They fought in vertical maneuvers, climbing and diving to maintain energy advantages, never allowing themselves to be drawn into the horizontal turning fights where heavier American aircraft might use their superior diving speed and structural strength. American pilots who tried to dogfight Zeros on Japanese terms seldom survived the encounter. The comprehensive testing program at North Island generated insights that transformed American tactical doctrine within months of the Zero's capture. Commander John Thatch, who had narrowly survived multiple encounters with Zeros over the Coral Sea and at Midway, participated extensively in the evaluation flights and immediately recognized both the captured aircraft's capabilities and its vulnerabilities. His analytical mind, trained through years of tactical study, began synthesizing a combat approach that would eventually save countless American lives throughout the Pacific theater. Thatch's testing revealed that while the Zero dominated in slow-speed turning engagements, it possessed critical weaknesses that skillful pilots could exploit. The lightweight construction that enabled its remarkable maneuverability also meant the aircraft's control surfaces became almost impossible to move at speeds exceeding 300 miles per hour. American fighters, particularly the Grumman F-6F Hellcat, then entering production, could dive at speeds approaching 400 miles per hour while maintaining full control authority. This speed advantage created tactical opportunities that had been invisible before the captured Zero revealed the truth. Additionally, the Zero's lack of armor protection meant that American heavy machine guns, particularly the .50 caliber Brownings that armed most Navy fighters, could inflict catastrophic damage with even glancing hits. While Zero pilots could absorb no battle damage, American pilots sat behind armor that could stop enemy rounds and flew aircraft with self-sealing tanks that could take multiple hits and continue fighting. This asymmetry fundamentally altered the risk-reward calculation in aerial combat once American pilots understood and exploited it. The tactical doctrine that emerged from these revelations became known as the Thatch Weave, a defensive formation that allowed two American fighters to provide mutual support against faster, more maneuverable opponents. The technique involved pairs of aircraft flying parallel courses with sufficient separation that if a Zero attacked one fighter, his wingman could turn toward the attack, bringing his guns to bear on the enemy aircraft. The Zero pilot then faced an impossible choice: continue his attack and be shot down by the wingman, or break off and lose his advantage. Documentation from the Navy's Fighter Director School, established in 1943 at San Diego, shows that the thatch weave became required instruction for all fighter pilots deploying to the Pacific. Training directives issued in September 1942 explicitly instructed American pilots never to attempt turning dogfights with Zeros. Instead, they were to use their aircraft's advantages: superior speed in dives, better high-altitude performance, heavier armament, and protective armor. The new tactics emphasized hit-and-run attacks, diving from superior altitude, firing during high-speed passes, and using speed to escape before the Zero could maneuver for a counterattack. Pilots who had survived early war encounters by instinct now had systematic doctrines supporting their survival tactics. The psychological impact of understanding the Zero's vulnerabilities proved nearly as important as the tactical lessons. American pilots had fought the first 6 months of the Pacific War believing they faced an invincible opponent, a technologically superior aircraft that doomed them to defeat regardless of their skill or courage. The captured Zero revealed the truth. The enemy aircraft was formidable but not invincible, dominant within specific tactical conditions, but vulnerable when forced to fight outside those parameters. This knowledge transformed morale across the entire Navy fighter community. Lieutenant Commander Edward O'Hare, who had won the Medal of Honor for single-handedly defending the carrier Lexington against a Japanese bombing attack in February 1942, participated in advanced tactics development using the captured Zero as an adversary aircraft. His insights proved particularly valuable because he had actually defeated multiple Zeros in combat before anyone understood the aircraft's weaknesses. O'Hare's combat reports, when compared against the Zero's actual performance characteristics, revealed that he had instinctively employed many of the tactics that would later become standard doctrine. Through interrogations of captured Japanese pilots and translation of recovered documents, American intelligence officers gradually reconstructed the experience of Zero pilots who had dominated the Pacific skies during the war's opening year. These accounts, compiled in reports that remained classified until the 1970s, revealed a warrior culture that accepted the aircraft's vulnerabilities as necessary prices for tactical superiority. The psychological framework that made Japanese pilots effective in unarmored aircraft provided insights into a fundamentally different approach to aerial warfare. Petty Officer First Class Saburo Sakai, who would survive the war despite catastrophic injuries suffered in 1942, later wrote extensively about the mindset of Japanese naval aviators. His autobiography, published in 1957 under the title Samurai, described the brutal training regimen that transformed young recruits into elite fighter pilots. Training began with basic discipline that included beatings for minor infractions, deliberate deprivation of food and sleep, and constant physical conditioning that pushed men to their absolute limits. The philosophy held that warriors who could endure any hardship would not fear death in combat. Flight training emphasized individual skill development to levels that American programs never attempted. Japanese pilot candidates spent hundreds of hours in basic aircraft before transitioning to fighters, practicing aerobatics and formation flying until these maneuvers became reflexive. Advanced students engaged in mock combat that often resulted in actual collisions and deaths, losses that instructors considered acceptable costs of producing superior pilots. By the time aviators reached operational squadrons, they possessed flying skills that few American pilots could match. This extensive training created a pilot corps that could exploit the Zero's capabilities while accepting its vulnerabilities. Sakai described combat missions over New Guinea and Guadalcanal, where he flew for hours at altitudes where oxygen deprivation caused confusion and exhaustion, engaged in multiple dogfights, and returned to base with fuel gauges reading empty. The Zero's exceptional range made such missions possible, but they demanded physical endurance and mental discipline that only the most rigorously trained pilots possessed. The lack of armor protection was not discussed as a deficiency, but rather as evidence of the aircraft's offensive purity. Japanese tactical doctrine emphasized avoiding enemy fire through superior maneuverability rather than absorbing it through passive protection. This approach worked brilliantly during the war's early phase when Japanese pilots possessed significant skill advantages over their opponents. American pilots fresh from abbreviated training programs could not compete with aviators who had spent years perfecting their craft. However, interrogation reports revealed that even veteran Japanese pilots understood their aircraft's deadly weakness. Chief Petty Officer Hiroyoshi Nishizawa, interviewed after the war by historians researching Japanese naval aviation, admitted that every Zero pilot flew with the knowledge that any combat damage would likely prove fatal. The unprotected fuel tanks meant that a single tracer round could create an inferno that left no possibility of escape. This constant awareness of mortality created psychological pressure that American pilots, protected by armor and self-sealing tanks, never experienced to the same degree. The cultural context that made this acceptable reflected Japanese military philosophy that valued collective victory over individual survival. The Bushido Code, adapted from samurai warrior traditions into modern military doctrine, emphasized duty, honor, and willingness to sacrifice personal safety for strategic objectives. Zero pilots were expected to press attacks regardless of risk, to continue fighting despite wounds or mechanical damage, and to choose death over the dishonor of surrender or retreat. This mindset made them extraordinarily dangerous opponents, but also contributed to unsustainable casualty rates that would ultimately cripple Japanese naval aviation. Part 6. The Turning Tide. The operational impact of the captured Zero's revelations manifested dramatically during the Guadalcanal campaign throughout the second half of 1942. American pilots armed with new tactical doctrine and understanding of their opponent's weaknesses began achieving results that would have seemed impossible just months earlier. The grinding air battles over Henderson Field and the surrounding waters became a laboratory where theory translated into survival and victory, forever changing the balance of power in Pacific skies. On October 26, 1942, during the Battle of the Santa Cruz Islands, Navy pilots flying from the carrier Enterprise employed the thatch weave and high-speed attack tactics against Zero fighters protecting Japanese bombers. Lieutenant Stanley V. Tasa, flying an F-4F Wildcat that was theoretically inferior to the Zero in almost every performance category, shot down 7 Japanese aircraft in a single engagement by refusing to engage in turning dogfights, and instead using diving attacks that leveraged his aircraft's superior structural strength and firepower. His after-action report explicitly credited the tactical doctrine developed from studying the captured Zero. The Marine squadrons defending Guadalcanal, operating under impossible conditions from a dirt airstrip that was regularly shelled by Japanese warships and bombed by Japanese aircraft, became legends by applying lessons learned from the captured aircraft. Major John L. Smith, commanding Marine Fighting Squadron 223, instituted mandatory briefings where pilots studied the Zero's capabilities and weaknesses before every mission. His squadron destroyed over 100 Japanese aircraft while suffering relatively light losses, a kill ratio that would have been impossible without the intelligence provided by the captured fighter. Statistical analysis compiled by the Naval Historical Center demonstrates the dramatic shift in combat effectiveness. During the first 6 months of 1942, Japanese pilots achieved kill ratios approaching 5-to-1 in their favor across most engagements. By the end of that year, after American pilots had absorbed the tactical lessons from the captured Zero, those ratios had reversed. American pilots were destroying Japanese aircraft at increasingly favorable rates despite often flying numerically inferior aircraft in terms of raw performance specifications. The introduction of new American fighters designed with knowledge gained from the Zero accelerated this trend. The F-6F Hellcat, which entered service in January 1943, incorporated lessons learned from the captured aircraft while maintaining the American philosophy of pilot protection and robust construction. The Hellcat possessed armor protection, self-sealing fuel tanks, and heavy armament, everything the Zero lacked, while matching or exceeding Japanese performance in speed and climb rate. The aircraft represented American industrial might and engineering philosophy applied with precise understanding of the enemy's capabilities and weaknesses. Chance Vaught's F-4U Corsair, with its distinctive inverted gull wing and massive 2100 horsepower engine, took the performance advantages even further. The Corsair could exceed 400 miles per hour in level flight and possessed diving performance that left Zeros helpless. Marine pilots flying Corsairs from Guadalcanal and later from bases throughout the Solomon Islands achieved kill ratios exceeding 10-to-1 by ruthlessly exploiting the tactical doctrine developed from studying the captured Zero. They dove from altitude, fired during high-speed passes, and used their superior speed to escape before Japanese pilots could maneuver for counterattacks. The Japanese responded by attempting to modify the Zero with additional protection and increased engine power, but these efforts largely failed. Adding armor and self-sealing tanks increased weight, which destroyed the precise performance balance that made the Zero effective. More powerful engines were difficult to produce in sufficient quantities given Japan's limited industrial capacity and the increasing effectiveness of American submarine warfare against Japanese supply lines. The Zero remained fundamentally unchanged throughout most of the war, growing increasingly obsolete as American aircraft and tactics evolved. By mid-1943, the air war in the Pacific had transformed completely. Japanese naval aviation, which had dominated the war's first year, began suffering catastrophic attrition rates that its training infrastructure could not replace. The captured Zero had provided Americans with the knowledge necessary to neutralize Japan's qualitative advantages in aircraft performance and pilot skill, while American industrial production created overwhelming quantitative superiority that Japan could never match. Part 7. The Human Cost. The strategic implications of the Zero's design philosophy became tragically apparent as the war progressed, and Japan's initial cadre of superbly trained pilots succumbed to the grinding attrition of sustained combat. The aircraft that had seemed invincible in the hands of veterans became death traps when flown by the hastily trained replacements who increasingly filled Japanese squadron rosters after 1943. The captured Zero had revealed not just tactical vulnerabilities, but the unsustainable human cost of the Japanese aviation philosophy. Japanese training programs could not replace pilot losses at rates that sustained combat demanded. The exhaustive multi-year training regimen that produced pilots like Saburo Sakai and Hiroyoshi Nishizawa required time and resources that Japan increasingly lacked as American forces advanced across the Pacific. By 1943, training was compressed from 3 years into months, producing aviators with barely sufficient skills to take off and land, much less engage in combat against increasingly experienced American pilots flying superior aircraft with tactical doctrine designed to exploit Zero weaknesses. These inexperienced Japanese pilots died in horrifying numbers. The unarmored Zero that had protected veterans through skill and maneuverability offered no forgiveness for mistakes or bad luck. American pilots reported encounters where single bursts of .50 caliber fire transformed Zeros into fireballs, the unprotected fuel tanks igniting instantly and leaving no possibility of pilot survival. The lack of armor meant that even non-fatal wounds became fatal when pilots lost consciousness and crashed. Parachuting from burning aircraft became the only survival option, but over water, this often meant slow death from exposure or shark attacks. Statistical records compiled by both American and Japanese sources after the war revealed the staggering scale of the carnage. During 1942, Japanese naval aviation lost approximately 1,000 pilots killed or missing. In 1943, that number exceeded 2,500. By 1944, Japanese naval aviation was effectively destroyed as a coherent fighting force, with pilot losses exceeding 5,000 in a single year. The Zero's vulnerability to battle damage contributed significantly to these losses, turning what might have been survivable encounters in armored aircraft into fatal catastrophes. American pilot accounts from the war's later years described encounters that were less combat than execution. Lieutenant Commander Alexander Vrasiu, who would finish the war as the Navy's fourth highest scoring ace with 19 victories, described a mission on June 19, 1944, during the Battle of the Philippine Sea where he shot down 6 Japanese aircraft in 8 minutes. His combat report noted that the enemy pilots seemed poorly trained and that their aircraft exploded with even minimal fire damage. The encounter, later called the Great Marianas Turkey Shoot, saw American pilots destroy more than 300 Japanese aircraft in a single day for minimal losses. Japanese accounts confirmed the horror from the other perspective. Warrant Officer Kiyoshi Ito, one of the few veteran pilots who survived the war, described missions in 1944 where he led formations of inexperienced pilots who panicked under attack and died within minutes of engaging American fighters. He watched men he had trained for weeks incinerated in their unarmored aircraft, unable to protect themselves or execute the tactics that might have given them survival chances. The psychological burden of watching the slaughter proved almost unbearable. The captured Zero had revealed that Japanese design philosophy prioritized mission performance over pilot protection based on assumptions about pilot skill and tactical employment that proved unsustainable in prolonged warfare. The aircraft worked brilliantly when flown by masters who could exploit its advantages while avoiding situations that exposed its vulnerabilities. It became a coffin for the inadequately trained replacements who lacked the skill to survive in an unforgiving machine against increasingly capable opponents, employing tactics specifically designed to kill them. By 1945, Zero pilots faced not just tactical disadvantages, but a psychological burden that affected combat effectiveness. They flew aircraft they knew offered no protection against opponents flying superior machines with protective armor and overwhelming numerical advantages. The samurai spirit that Japanese culture celebrated could not compensate for the hopelessness of the situation. Suicide tactics, kamikaze attacks where pilots deliberately crashed explosive-laden aircraft into American ships, became increasingly common, partly because conventional combat had become so one-sided that trading one's life for a confirmed kill seemed like the only way to achieve meaningful results. Part 8. Legacy and Lessons. The abandoned Zero discovered in the Aleutian Islands on June 5, 1942, ultimately contributed to American victory in the Pacific War, far beyond what any single combat engagement could have achieved. The intelligence extracted from that captured aircraft cascaded through American aviation doctrine, aircraft design, pilot training, and tactical development, creating advantages that accelerated Japan's defeat while saving countless American lives. The lessons learned from examining the enemy's approach to fighter design remained relevant long after the war ended, influencing aviation philosophy for generations. The captured Zero, restored to flying condition and extensively tested throughout the war, continued serving in research roles well into the 1950s. The aircraft, designated EB-2 by American forces, flew demonstration missions at Navy training facilities where new pilots could observe firsthand the enemy aircraft that had once dominated Pacific skies. These demonstrations reinforced tactical lessons and maintained institutional knowledge about the importance of understanding enemy capabilities. The aircraft eventually found a permanent home in the Smithsonian Institution's National Air and Space Museum, where it remains displayed as a testament to the aircraft's historical significance. The broader lessons about aircraft design philosophy sparked decades of debate within American aviation circles. Some engineers argued that the Zero proved that excessive weight devoted to protection compromised performance to unacceptable degrees. Others contended that American philosophy, accepting performance penalties to ensure pilot protection, reflected superior long-term thinking that enabled sustainable combat operations. The Korean War, which began in June 1950, reignited these debates when American pilots encountered Soviet-designed MiG-15 fighters that incorporated some Zero-like characteristics, including minimal armor but exceptional performance. The human dimension of the Zero story resonated most powerfully in post-war analyses. Military historians examining Pacific air combat recognized that the captured aircraft had revealed fundamental differences between American and Japanese military cultures. American forces treated their personnel as valuable assets to be protected and preserved. Expensive trained manpower, representing years of investment that should not be needlessly squandered. Japanese forces, influenced by warrior traditions emphasizing honor over survival, accepted casualty rates that Western military culture found shocking and ultimately unsustainable. This cultural analysis extended beyond aviation into broader examinations of how different societies approach warfare. The Zero's lack of protection reflected Japanese acceptance of individual sacrifice for collective goals, a worldview that produced initial tactical successes, but could not sustain industrial-age warfare's grinding attrition. American emphasis on protection and preservation of trained personnel, while reducing aircraft performance in some categories, enabled the long-term force sustainability that ultimately proved decisive in extended conflict. The individuals whose stories intersected with the captured Zero lived varied post-war lives that reflected the conflict's complexity. Commander John Thatch retired as a four-star admiral in 1967 after a distinguished career that included command of carrier forces and senior staff positions. His tactical innovations, born from studying the captured Zero, remained standard doctrine throughout his career. Captain James Miller, who first examined the captured aircraft in Alaska, worked in naval aviation development after the war, and contributed to jet fighter programs. Lieutenant Commander William Leonard survived the war with 8 aerial victories and later taught tactics at the Navy Fighter Weapons School, the Top Gun program, that continued emphasizing the lessons learned from the captured Zero. Japanese designer Jiro Horikoshi, whose engineering brilliance created the Zero, survived the war and lived until 1982. He never designed another combat aircraft, but worked in Japan's post-war aviation industry and wrote extensively about the Zero's development. His memoir, published in 1970, expressed no regrets about the design choices that created such a lethal yet vulnerable aircraft, noting that he had fulfilled the requirements given to him by naval aviation authorities and that the aircraft had performed exactly as designed. The story of the captured Zero ultimately transcends simple narratives about technology or tactics, reaching instead toward fundamental questions about how societies wage war and value human life. That abandoned aircraft in an Alaskan marsh became a window into enemy thinking, revealing both brilliant engineering and fatal vulnerabilities that changed the course of history. It demonstrated that understanding your opponent's capabilities, limitations, and underlying philosophy can prove as decisive as raw military power. The Marines who discovered that Zero on June 5, 1942, had stumbled upon one of the Pacific War's most significant intelligence coups, an advantage measured not in meters of territory captured, but in thousands of lives saved through knowledge gained and properly applied.